because I close. There's no way to make the camera stay going when you close it. Why? There's so many reasons why I need it to. Or why?
Yeah, I know what you mean.
What the hell?
There's probably an app that you can do that.
Well, there better be. That's so retarded.
Yeah.
You could lose, like, you could get charged with a murder because it missed the thing you needed. Like, and there's no limit to what that could cause. Now I have two videos for the stupid thing. Okay, so here you've got a black hole. Now people get confused about black holes because A, they're invisible. B, they have too much power to weight ratio. They have more gravity than the sun if they were the same size, and people don't understand. So people think it's a whole different being. They don't realize that the asteroid is rock, the moon is rock, the planet is rock, the sun is nuclear fusioning at the surface, rock. And the black hole is no nuclear fusioning rock. Biggest piece of rock. And it's exactly what it is. Now, so, seeing something just means that it reflects light, Light comes in 7 different colors, and every item is reactive to some combination of those 7. And they blend, and there's only 7 colors. When you see something and you think it's like purple or whatever, it's actually not. It's blue and green, and I don't know what color. I'm not, like I said, I don't care what. So, but you're actually seeing blue and green so close together that when you back up, your stupid big ass sees purple. Purple's not a real thing. Well, this is all hypothetical. I'm not doing real colors. I'm just saying, the theory behind it. Right. So, there's only 7 colors that when you zoom in, you can see as standalone colors. They literally are just dots. Like you can have 7 dots to 3. You can have every different ratio of every different. Like you got 7 colors, and you can have any ratio of any different 7 you want. And that's how the whole spectrum is made. And you can just find out. I don't know why light is reflective and why. Now the light that's not reactive to it means it's not reactive to it. When it goes into it, it hits it and it stops, but it doesn't show up on it, and it can't be seen through it behind it. So only 2 of the 7 will say like bounce off, and so that's the 2 that make the color. But the other 5 hit it, and they don't collide with it, but they end at it without colliding. They just can't go through it, but they end. And so the black hole, if it's invisible, well, it obviously doesn't reflect any of the 7. So, however, if I have a cow out in the space out here floating, and it goes behind the black hole, I won't see that cow. But I also won't see the black hole. What I will see wherever the black hole goes is a lack of seeing what I should see. I won't see through it, but I won't see it either. I'll be like, there's a smudge on the lens, but I can't see it. I can't see. Like I lose you. I regain you when you get over here, but I can't see you when you're right here. I could take this like a magnifying glass, move it around anywhere I want. It blocks out what I'm seeing. If I said, okay, well then what do you see where you can't see what you're used to see? I'd be like, nothing. Mm-hmm. Like, it looks like nothing. It's there because I can't get light to go past it, but it's nothing. So it is essentially a black hole. It is essentially a black piece of coal. It is essentially, now, flat black is not supposed to, flat black is the color that you see when no light waves come back. Mm-hmm. And we don't have any form of perfect flat black because we can't get a perfectly flat application. So the waves, will reflect the light a little bit so we can still see our flat black paint and stuff. We're not perfect yet. Humans will eventually have like 17th generation fucking multiple black hole fucking forged flat black in a super pressurized applicator that will make things invisible, But you won't be able to. You'll still see the profile of them, so they won't be invisible. But you won't be able to see them, and but they will block what they're in front of. And so this is very clear to see. I can tell you for just two ways. This is where I completely original. I don't want the world to know this yet. So why can't I see any of? Just watch this. This is the first part that's really going to blow your mind. Okay, so why can't I see the black hole? Well, let's see. I'm a human. I see things on a certain scale. They can get too big or too small for my human scale. Now, so let's go to a demonstration to show why you can't see it. Then I'm going to show why it has too much power for its size. And then you'll pretty much understand that I get it. Now, I also can explain the algorithm that I've developed to have done all of this. I have a way of each problem of this. I mold over each little step that I'm giving to you in one presentation. Over 25 years of my life, I've stopped on each step and thought about it for hundreds of days or several years until I understood it, and I slowly began to formulate a algorithm of how I'm coming to these conclusions and what I need to do to verify each epiphany if it's true or not. And I can even explain that. But first, this would be all prerequisite to something like that. But I have explanations for the explanations, and then explanations of how the explanations before the explanations, and then everything. So and it ends with a whole new fundamental ideology of science that I can easily teach you at the end. This won't all happen today. I'll stop this soon. But I have it all the way, full circle. If you listen to my presentation and you understand it, then I also know what we need to do about it as mankind. And I have as valuable of a little packet as any of your Charles Darwins or anybody of the past. I'm the next one. I'm starting from today's starting point, but I'm also cutting off a lot of stupid stuff that will all be explained in the new fundamental approach to science that I can outline at the end of this. Would be a lot of that will be explained then. But okay, so I like to imagine this as a shoebox and ping pong balls. Now, let's say charcoal is about the most flat black thing on Earth, right?
Yeah.
It's it's the most blackest element.
Black, yeah.
I bet a lot of paint. I don't know, but if I was making black paint, I would start by experimenting with charcoal. I'm assuming there's probably some black charcoal in black paint. I don't know, but why wouldn't there be? Mm-hmm. Okay, so I don't see anything else black on Earth. Do you? Burnt wood? That's brown.
I mean, yeah.
We have brown paint too, so that's not going to work. Charcoal is a good, solid. Yeah. So now, what could I imagine a burned out sun that doesn't blow up would be more made of, than charcoal? Now, the burnt out black hole is going to be obviously very charred in nature and burnt. It's the most burnt it can possibly be. Now, granted, when a supernova occurs and it blows up, it's not all black, but that's because maybe the black hole is only black on the surface mainly, like a cooked piece of a nugget. You bite into the center and it's still moist.
Yeah.
So the surface, it might be where all the heat radiates the most, and or let's say that in the center it's the hottest. And maybe that in the hottest, it's all diamonds and crystals, because we don't know. Maybe there's a point where it's burnt, and then it's like a geode. But either way, it doesn't matter. When it blows up, it's not all black, right? Because Earth's not all black, and everything came from blowing up of these. All of our little asteroids. But they came from the center of this and all over this, and it might just be that the surface is black, which might be where coal comes from. Just to make this simple, everything's gonna, if it's plausible and it's not proved wrong, then it's right, because physics plausible means that it can occur because due to physics, and that's what all that matters. So, yeah. Now you've got so let's just say that some particles on a black hole's surface are true black. Let's just say a small percentage of them. And we're going to just say that because they're burnt. Every bit of light reactivity that they had in them is burnt off. And they're like, they have no fingerprint. So when you shine light at the black hole, only these little dots you would light up anyway. And it has a portion of it that is so charcoaled that it just is now it's now I would wager to say that we can find maybe the surface might be nothing of a black hole, because when they blow up, that's like the eggshell, and the egg's so big. Maybe we've never found a piece of the black hole surface. Maybe coal doesn't do it justice, or maybe we have. I don't know, but I'm gonna say that there's some, but there doesn't even have to be. My theory has two ways of achieving this invisibility, but we're gonna say that for the sake of this first one, we're gonna say that there's 10% of the surface is non-reflective. So, and that doesn't have to be true. It probably is. I have another follow-up theory that will make it true. And this one is also never ending in perpetual nature if you want it to be, and eventually will become true. Because watch this. Even if it's 100% of it, even if it's 100%, non-true black, let's say it's 0% true black, this will still work. So 10% of the moon, or of this, now these are now ping pong balls, and this is a shoebox, and I'm gonna put 10 ping pong balls in the shoebox, and let's just do like 20%. So 2 of them are invisible because those don't reflect light. So now you see all those and you don't see those. And now what happens if we put 20 balls in the same size box, same size balls? Well, each ball has to crush to half the size. It's the only way we can do it. Okay, so now you've got 4 of these that you can't see. Okay, now let's do it again. Now you've got 8 of them that you can't see. And however, each time you can't see them, they're getting smaller and smaller and smaller. And there's more that you can see, but the ones that you can see are getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. And now, pause. Just go ahead and do that 16 billion more times. And then tell me that you can still see those balls.
Oh, no.
They're too small.
Yeah.
So, and remember, the black hole stopped getting any bigger billions of eons ago. It just keeps packing in. So it's shrinking its golf balls until ping pong balls until so once it's all the way down to invisible, it has a ton of visible balls still, but they're too small for you to see. Because we give me a super duper telescopic microscope or something, and I could maybe see them. But my eyes are like, no, there ain't nothing there. I can't see them because they're micro fucking scopic balls. Mm-hmm. And nuclear fusion is where all the physics hit the road because the material has fell in on itself. So now things that don't compress, things that you can actually, now you can guaranteed shrink the balls. Because you're in nuclear fusion, so everything is fucked. It's the back is already, mom's back's already broke. So now these balls are getting shrunk, and then we're gonna pack it in billions of times over because we're fucking universe. Universe ain't no joke. And so these 2 little balls you can't see them anymore. And so that's one. That's only half of why. Let me see what the other one was. Or no, that's it. On why it's invisible, because the 2 are that some were invisible to begin with. So if I just keep shrinking it down and just keep shrinking it down, I get more and more and more invisibility, not in percentage but in number. Mm-hmm. So if I do it 16 billion more times, now I have 32 billion invisible elements. That's gotta help. And so then on top of those now having 32 billion invisible elements, the visible ones are so fucking small, I don't think I can, they're not visible anymore. Yeah. So boom, invisible. I mean, or it just plain fingerprint is all the way burnt off, period. You know what I mean? Maybe this, but you know it's both. These balls are shrunk down, but let's say they don't even need to be. Let's say I can take one of these balls, any one of these balls I want, and they're all true black. And that's possible too, because it's the most charred fucking thing in existence.
Yeah.
And so humans say someday we'll be able to create a true black. Well, no, we won't. Not if that's not. So that probably is. Because why do we say that? We're just waiting to get the eggshell, you know? Mm-hmm. Okay. So that's a black hole. So a black hole is interesting because the world doesn't know what it is, and it's really simple what it is. And so you've got black hole. Oh, so like when in your little game of putt-putt with your spaceship, and it's like, whoa, the black hole is pulling the hardest, but you don't see it unless it blocks something. I need something to go by it and disappear for me to see it's there. Like I need Earth to sweep by and go and whoop, disappear, and then whoop, reappear. And there's a black hole right there. And so that motherfucker is sucking you the hardest. That's like not much more than the sun. The sun is pulling you about the same amount, but that's an invisible sun, and the sun pulls hard. So we gotta know where those are. And now there's 2 more things, and then we're done for the day. The black hole is why is it? So the black hole, thankfully, is actually highlighted with a glowing orb around it. Just an orb. And planets don't have that. Nothing else has that. Just the black hole has that. So I have to explain that because I explain the whole system. I have to explain why the black hole is more powerful. Because a star, if it has this much mass, it's all completely proportionate. Like 10 units of star equals 10 units of gravity. 100 units of star equals 100 units of gravity. The star never deviates. We can go look at any star we want and put it on the scale and then check its gravity and the same amount, mass per power, unit per power, pound per gravity. And then you go to the black hole, and it's only a cunt hair off. The black hole is like when you get 10, you get 10. When you get 100, you get 99. When you get 1,000, you get 995. And people are freaking out over that. Now you want to know what that is? That's simple as fuck for me to tell you. That's because it still has the same amount of mass. When it turned off, remember it used to be glowing, it used to be expanded, and it used to be hot. And then it shrunk when it cooled down and turned off. And so right off the bat, a black hole should be expected to see this because it is the same mass that it used to be, but it's not as big. So when we look at it, we're going to say it's not as big as that. This star is bigger than this black hole. And this black hole has more power. More power. Or less. Or, well, we'd say more because it's smaller. And so if it was the same size as that star, it would have 1,005 per 1,000. And we're confused because all stars stay equal at the 1,000, and this thing is slightly off kilter. So we're just fascinated that it's different, period. And so we call them super duper powerful and shit. They're only a cunt hair more powerful than the sun. And that's because the sun, not only is the sun is expanded thermally, and the black hole is shrunk. Think about the sun. It's also beaming light. And when we look at the sun, where do we know what our eyes see as sun and light distortion around it, Let's say the sun didn't shrink from thermal dynamics when it shut off. Let's say it stayed the same size. Don't you think it would still be like blinking an eye half closed from the light going down?
Oh, yeah.
So the sun is this big, but we see it that big because of the light orb around it, right? You would imagine. Like, it's just beaming, you know? And a lot of this is just light. That's one. I mean, that's part of my theory. So that's the only two parts needed, though. Between it shrinking when it shuts off, but it not losing any weight, it just getting smaller. So if you could actually weigh it, you'd be like, well, it has 1,000 units right here, and it has 1,000 units right here. What are you talking about? They're both the same. Well, because this one's not as big as this one. Okay, well, they both weighed the same. So, and remember, we already determined that it goes off of mass. So, because if you have more mass in here, if you put a bunch of styrofoam in there, you gain mass slowly, but you also push slower against this wall. You also, everything is the same scale. If you want to throw a bunch of iron in here, you grow fast, but you push back harder. So, you are going to get the same amount of gravity per mass. But mass doesn't determine size because thermal temperature affects size. And like I said, I could sit and pump styrofoam into this all day long and it would gain mass slowly and gain size hardly none. It could keep packing styrofoam in there. But then if I start packing iron in there, it's going to have to start growing because it's harder to do, you know, to compress it in there. But the iron is going to make it way more on the scale quickly, and this foam will not. So everything's going to stay proportionate in how many units of power you get back on gravity. You know, the styrofoam is barely going to up the gravity, and the iron's going to up it quick because the styrofoam is going to turn into a little pellet when it goes in here, and the iron can't do that, so it pushes on the system and gives it more power. But so the bottom line, this thing weighs 1 million pounds, and this thing weighs 1 million pounds, so they both have 1 million pounds worth of gravity. But however, this one's smaller than this one, so they say it's more powerful. Because if we made it the same size, then it would have more power. But that's because then it would be a bigger star burned out. So, and then on top of that, you've got the light dilution of your eyeball, thinking that it was actually this big when it was only this big, and then it shrunk on top of that, and that's that. That's that. And then the last thing is why is there a glowing light orb around the black hole? And it's the only thing that we think that has a light orb growing around it, but I don't think it is. So you've got your black hole, and you've got, just like all the other things. Now the black hole has a fierce following from its gravitationally motivated objects, and so they come in and they get caught in orbit from that magic speed, the magic number, the magic pole, and now they're coming in from all different angles, and then every once in a while you see one drop in, but for the most part they go forever in orbit around it. And so this orbit around here is getting ever more populated the longer it's a black hole, and ever more dense because it has a super lenient, wide racetrack of because basically so do all stars, but this one's so easy to see because it's not lit up, you know. Mm-hmm. And so you can really see the Daytona 500 going on around it, and then especially because it is anti-light. And so you've got all of these things come whipping in and get caught in its amazing pull, and because it not only is it a star, it's the biggest star possible, so it's 1 million suns, you know, already. And so this is a sight to behold just out the gate. And but when these things, when this thing's going 30,000 from its supernova and it starts getting pulled into the black hole, now that's one hell of a ski slope you've never thought about. So that downhill fall, this thing reaches upwards of 700 million or 660 million miles an hour is the maximum that these things can reach. And so that's one thing that you hadn't thought about yet. This little thing can go from a measly 30,000 to, before it gets here into the beltway, 600 million. and which is almost the speed of light, which means it can't go any faster, which means the thing that does not use light is almost as powerful as light. It can almost pitch. It's a pitcher that can almost throw as fast as light can move. And so as that, which means it can, because almost means like in rare, the perfect, it can. If it's just calculatably almost, then it can. So this thing's coming in at a cool 300 million. Well, this area is the Interstate 80 at rush hour. This guy doesn't have brakes and he doesn't care. So when he comes into here, he goes boom, and he plinkos those ding, 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 all those asteroids all over the place. And the first thing he does when he hits the first one is stick to it and start glowing. And then when it pulls, boom, 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 boom. It's a chain reaction because they all go all over the place. They all hit everywhere. And yeah, you're going to get some debris knocked in from it. And that's good. I suppose the black hole likes it. And but you're going to get a never-ending collision back and forth in here because you're going to keep having new ones come in. And so this is just a white rapids river over broken rock of hell that can't ever smooth out because it's constantly like the pool balls. Like when you hit a break and pool, this is the break of all breaks. This break, pow, it hits that and it dominoes all the way around the circle. And so every time. So this thing started glowing from the very entrance of its first impact. And then now when it plinkos back and forth, it's since it's going, this whole ring is going like millions of miles an hour because they all got sucked in by that power of that. They all fell down the hill and then missed the fucking ramp. So they are going to never quit having bickering with each other in here. And that they eventually, every time it bumps into another one, it gets another little piece of it glowing. Eventually, it's been, because when we're talking bump hard enough to fucking nuclear fusion on the surface. And once every ball in here has ran into every piece of its surface with another ball, they're all glowing. And then they never are going to go down because it's just a melee of bullshit and heat and speed, and they're continuing to crash, and it's just it's a kiln for them at that point. There's no way to fit any more of them in this area at this speed. Since they collide and glow, if they collide, they glow, you got too many of them going too fast to avoid colliding and glowing. Mm-hmm. And so, therefore, the black hole is now visible. It's almost like, hey, life, look here.
Come here.
No. Don't come here. I knew you wouldn't see this. I knew you wouldn't see this, life, so I highlighted it. And then, black hole. Never goes away, I don't think. I think it eats forever. And I think eventually what you have happen is it becomes a supermassive black hole, and I don't think it can do anything from there. I don't think it can blow up. I think it just puts things in it forever because it's never going to have another event where anything big happens. It's no longer lit. It's not fusioning. It's just chilling. And since it didn't blow, I don't think it can. Maybe it can. I don't know. But I think what happens from here is whole entire solar systems get caught in orbit because we're all moving. Remember the magic speed, the magic spot, and then you get that spiral that we've seen, and that is what that is so the spiral that you see would be as you get farther away from the black hole, the faster you need to go to orbit it. So things are just going faster and faster and faster, but they're all orbiting it. And so for some reason, it'd be simple if you saw it play out. Like if this was the actual size of the black hole and we could watch it on the wall with a projector, you would see why it's strung, why it's one string out. But those things are all it's like the way that they were how things modulate, like you have something spinning, like you make a painting where it's spinning and you just put the pen on it and it does cool things. There's these things are all spinning and moving. There's obviously a simple physics dynamic to why the contents of the orbiting things, like, okay, here's the sun and here's the planets orbiting the sun. They don't do that. They don't go like that, in one line. But that has to have something to do with you being so far away and looking at the big picture. And all this is actually the whole fucking thing, widthwise. So it's not actually one line going out. That is actually like as the shit was being spit out, it was being picked up. That's all of it. So that's like if you could see a model of the thing being little, that is just obviously. Now this is at the biggest level because we're talking. We can zoom down in here, and there's the Milky Way, and here's the blah blah, and here's the blah blah, and those motherfuckers are all going around this supermassive black hole that can't go away. And they have little black holes all over in here that are just the sun. Like, so we're talking right here alone, maybe like 800 billion suns. And so there's little dead suns all over in here. They're black holes, but this is the one that has been here the longest because think about it. Black holes are just rocks. So black holes get too close to black holes can orbit black holes can fall into black holes can get double the size because they ate a black hole. So you have the incumbent, the first one. It has many black holes in his tummy. Eventually, he gets the whole thing moving around him because everything's already moving. And the more power you have, the more likely it is to stay moving around you because that zone becomes easier to get caught in. And somehow he unravels the system in what looks linear. But that part, this is a good stopping point because I have my next thing to think about over the next couple of years or however long it takes till I can tell you why it's linear unraveled. And so then I want to write down what I need to continue with would be unravel the spiral shape of the black hole arbitration. I don't know if that's a word, but I mean, I nerd on my own words all the time. Okay, unravel the spiral shape of the black hole. Explain life on Earth now that the life cycle of Earth is understood. Because I got life. I know how life started on Earth. I can explain all that. Let's see. Then explain, like obviously, like high low tides and the moon. The reason why the moon is big, or how we got lucky with that. And then reason why technology is stuck. It went really fast for really short, like really quickly. It was advancing, and now it's Wow, I can't even read that tomorrow. Reason why technology is halted. No one knows. It's just, I mean, I'm calling it right now. Like, we're not going to have amazing new, like, things. Like, when they're like, future robots that do this and that, and, like, magic, this and that.
Like cars flying and shit.
Well, that's pretty possible. I mean, that's, but yeah, even like that. But, we're not getting that stuff like we think, because, that's what I'll explain. Technology it was going at a breakneck speed, and so we're all excited, and we just think, but, I guarantee right now is when it does this. And, it's not a coincidence. It's just that now is the time. I'm not just saying that because I'm here now. I'm saying it. I'll explain why. But I have the solution for that. That's at the core of all this. Okay. So reason why technology and so science reform. Let's see. So the science reform. Oh, and then problem solving algorithm that was experimentally used and purposely developed with intent and hope of using my subconscious to solve all these problems, not my brain, not the awake part. And so I came up with, I was thinking about how your brain has like a million gigabytes of bandwidth that we don't use, that is and then all the part we do use. And then I'm thinking, well, there's no part of the brain we don't use. That, I mean, nature doesn't do that. So the brain has a humongous section of it that we are not in. It's been lock and key from us. It's thrown. It's automatic. It's not needed. It doesn't know fun. It doesn't know the good, bad. It doesn't know. It's But okay. And what it is instinct. Instinct versus mental cognition. Explained. And then so I realized that instinct is running, even though it can't make decisions, it's a vast encyclopedia. And it's running on the most powerful part of your brain. However, it's not available for. It's like a race car that you'll certainly crash or something. So it doesn't. We don't have access to it. But it we'll just save it. It's on the list. But it's a really good one. It's really interesting. So I managed to tap into, and that's what I've allowed to do this whole thing, is the part of my brain that nobody uses for anything. And I found a way to make it work for what I can decide what I want it to work on. I found a way of manipulating it into, I just thought about it in most simplest way. And I thought, like, so people's gut, like, when you're just sitting there eating dinner, and you're like, I got it. Well, what did that? You weren't even thinking about it. Had to be your gut, your conscience, subconscious. You weren't thinking about it, so it had to be. And so it has a way of, when it gets excited, it can send you a flyer. Like, look at this. And I've been sending it invitations to join the debate, and I found a way to connect to it that works, and that's how I answered all these questions. And then like all this stuff I just did, I've used my algorithm one piece at a time, one step at a time, I have not had to really try much, because I just wait until it delivers me the banner. And then I plug that in. I do this again, and I get stuck at the next spot, and then I plug it into the system, and I let time do its thing. And I only spend time thinking about it when I want to, when it seems like an out of this world adventure. I only think about it when in a fun way. And otherwise, I'm always plugging the next thing through without work. And then the only work I put in, which also advances me, is have fun with it. I like to go to other worlds in my head, like that. Like, this takes me to other worlds, like I wasn't here while I was doing this. I was at each place that I was talking about, otherwise I wouldn't have understood it. That's how I was able to just, like, because I'm not actually, I mean, I'm self-trained, but I know physics so well that I'm able to start at square one and apply them through the whole range of systems, Like, all I was doing was applying physics we went from, now obviously we know, like, particle makes up, like, atoms, and atoms make up molecules, and molecules make up materials, and materials make up asteroids, and asteroids make up moons, and moons make up planets, and planets make up suns, and suns make up black holes, and they're all rock. But so are we. We're made of rock too. Oh, and there's one last thing I just needed to say. Hold on. So I did the sun, moon. Oh yeah. This is why Pluto became not a planet. This is quick and easy, and then we're done. And you realize I could do this for. I'd say that I have like a 4-year curriculum. I could teach. I've been doing. People have no idea. Nobody has the time and the brain capacity to understand exactly who I am. That's why I get so offended, or why I offend people when they try to tell me I'm wrong, because there's not a possible way that I am in comparison to them. They're talking about, like, I have theories of all that too. I have ideology and philosophy for days, hours, forever. I can go on forever. I could write like 4,000-page books on 4 different, like, one would be like life on Earth, one would be like the universe, one would be like human ideology and mind, whatever you want to. I'd title the book after I wrote it, but I'd start talking about human minds, psychology, and then like whatever I could. And then philosophy, but so you've got a planet. No, you don't. You don't. So when you have a sun, and then you have different debris orbiting it, and based on how big the debris is and how fast it's going, depends on what ring it can orbit on. So they're gonna all. Oh, and now keep in mind, you can also have you can have orbits that are ovals, like completely, because you can have this asteroid might have nothing over here and Jupiter right here. And so it goes over here and it almost falls into the sun because the sun's pulling it in, and then it doesn't though because it's in orbit. And then Jupiter sucks it way out here, and then it misses Jupiter, and then it almost goes back to the sun. And then so you can have any shape of orbit too, because then you could have Earth over here. So then you could have you could have you can have any shape of orbit because of all the features, every path, every mass, and every speed, and every interaction to the putting green decides the possibility of orbiting. And here's the final thing. It's not lost. I'll be right to it. Let's see. Okay. Orbiting. Let's see. I just had it. Orbiting Earth. Oh yeah. Okay. So let's make a smaller model so that I don't run out of space like I did. Okay, so there's the sun. Here's a bunch of debris. Here's an orbiting path. They're all on the same orbiting path. And here is the Earth. Now, the only possible way that all of these things on this path are going the same speed is if they're the same exact mass, because they are all on the same train track. And so they're all different sizes, because that's obvious the way physics and natural, it's obviously going to be random like that. There's too many different so you've got Earth going slower than all these little things, because it's harder. If Earth was going as fast as them, it would fucking launch out to hell because it's too big. So Earth is going to get ran into by all of these things eventually. Has no choice because they're on the same path. Mm-hmm. Earth is not allowed to be called a planet until the last one hits it. So you are a moon until your debris route is cleared. Once you have because we won't call it a planet if it's ever going to have a life-shattering, like the fact that Earth lost the dinosaurs that's not in our current understanding. if we see that coming, if we say that place is going to have a little flare up of life over there, it's going to be exciting for a minute and then it's going to dinosaur out, then it's not a planet, it's a doomed land. And only planets are promised lands. So planet means that the debris, the orbit path is cleared. Moon means round. Orbiting moon is in orbit. Rogue moon is flying. Planet means glowing, or no, that's a glowing moon. Planet means nothing else in its orbit path. You are not a planet until then. Pluto, remember Pluto we used to have? Remember they took it away?
I didn't know that they took it away.
Yeah, because Pluto, they found more debris in its path, and so they don't know what's going to happen to it whenever it finally eats it. And because it could blow it to smithereens, or it could knock it like a pool ball out of their orbit, or it could grow into a fucking super planet. Let's say it goes out to space. Let's say it gets giant. Let's say it crashes. What did it say? It hits it from this way and fucking takes it down. All of these things make it not Pluto anymore, based on what you call Pluto, that frozen little planet out there that's in just chilling around the sun. But if it was big and not there, then we would have to rename it, right? It wouldn't be Pluto. So mankind has too much pride in its intelligence that we don't ever want to have one called a planet when it gets taken away. And so Pluto, we're in the clear because we didn't see the danger before, and as soon as we saw it, we said that's not a planet. So now we're covered. Now we don't care now if Pluto gets blown to smithereens. We can be like, haha, we told you. But if it survives the ordeal, then and is still the same size in the same spot relatively, then we can call it Pluto again, or we can call it Pluto B. You know, we'll say it's a little bit hotter, a little bit closer, a little bit bigger, but it's Pluto. We have to wait and see what happens though before we can. So until then, it's on standby, and this goes on to so much more. I'm gonna try to stop it though. I had some more notes I wanted to put, but I probably could just trust myself to just play the last 10 minutes of video next time and then just kind of start from there. But I want to talk about, so then we talked about everything eating everything, everything combining to everything, a black hole getting too close to a black hole, black holes orbiting black holes, because black holes are rocks. They can do everything that everything else can do. They're one big rock. Supermassive black holes spiraling out whole galaxies. Oh yeah. Okay. Now that I know all this, I also know. So I know what a black hole is. That's the start of something great. Now I also know, the question, is there other life out there? Or some people like to say, is there like an alternative, or what's it called? A fucking parallel universe with me in it? Oh, buddy. Absolutely. And that's really easy to explain why. Because, so imagine Earth is a Lego castle with, we're just going to say 20 trillion pieces. And those pieces are every atom on Earth. Every atom on Earth. Well, you're made up of atoms on Earth, so are all the rocks, so is the whole Earth, so is every animal on Earth, so is everything on Earth. So there's only so many different ways you can arrange all 20 million Lego blocks. In this way that it's currently arranged, it has me and you in it. And we could shift around just a couple blocks and get rid of me and you, and it would be almost the same place, but it would be a little bit different. And because there's 20 trillion Lego blocks. Now, realize that now these numbers are fake, but there's more planets in just our galaxy. Okay, hold on. Their solar system is small. That's how many planets go around one star, because solar means star. So there's 9 planets, 8 because we lost Pluto, in our solar system, which is Earth's solar system, the sun. Then you've got the Milky Way, which is the galaxy, which is a bunch of solar systems in a cluster around a black hole. Then you've got the universe, which is trillions and trillions of galaxies. So you've got the solar system, 9 planets. You've got Milky Way galaxy, 19 trillion planets, we'll say. Even though that's not, we don't know. We don't know. And then the universe, 19 trillion. The reason I chose 19 is because I put 20 pieces here, but that's actually wrong. I need to change this to 18 because this is already proven. This we can calculate just by doing a sample size and then grading out with that sample size of what we think the size is, and we already know. Milky Way galaxy, 19 universe, let's just say 25 trillion galaxies. Okay, and now universes, unlimited and endless. They don't stop. These stop because we had to get to the next thing, but the field, we don't know if it does or don't see. It does probably because we're a living thing, and living things have a size, but it's too big for us to know. And now, so me and you are right here, and so we got 18 trillion different. So let's just talk about total combinations. Let's just say there's 18 trillion different combinations, 18 trillion different Lego castles you can build. Well, there's 19 trillion of them built. So it's impossible to, or no, we need double. We need, there's 18 trillion, so we need to say 30, let's just say 50 trillion of them are out there, and there's only 18 trillion combinations. So there's 3.5 times over. So based on mathematics, there's 3.5 Earths out there exactly to Earth. Exactly to Earth. Exactly to Earth. Meaning me and you are having this conversation in 3.5 places. Has to. It has to. And this math is, these numbers are fake, but this math is right. And there is no possible way around it that there is the exact same. Now you could fly for light years and 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 check trillions of places, and you could go to a place that's 99.998% the same as us, and me and you'd be there, you'd be 6'2" and I'd be 6'4" or whatever. But that wouldn't be, that doesn't even count. There has to be 3.5 places exactly the same, because there's only so many there's more castles than building blocks, and that's fucking insane.
Are we all doing the same thing? Maybe
no, that doesn't have to be, but so we're gonna probably do similar things quite often. But all that has to happen, let's say you go to a Petco and buy 3 pet cages that are exactly the same, and you put exactly the same amount of bedding in each one, exactly the same 3 hamsters from the same litter. You made sure that they all weighed the same and had the same vet care their whole life and the same meals. You separate them for dinner and they both get the same amount of morsels of food, and everything is identical as fuck in your 3 hamster cages. That's what we would have. You'd be this hamster, and this hamster. You look the same. You'd be the same. It'd be you. You'd be like, hey, I'm Chad. And you'd be like, so am I. And if you said, I'm not Chad, I'm Ted, then I'd say, get that one out of here. That one's all right, you know? Because in this one, you're Chad. And now that's the bad example. That was just representative, but scratch that. You don't have to be Chad. But you look the same. You are the same. If I could break apart your atoms and build you like a puzzle, it's the same puzzle, and so you most likely, now I could definitely take this Chad from here and insert him in this guy's life here, and he'd be good at it because he's the exact same Chad. You need the same prescription glasses, the same And if any of that's off, then it's just a 99.998er and get it the fuck out of here. We're looking for the match because based on mathematics, there's a match out there. So just go another billion years and look again. So you'd have three and a half hamster cages of the same hamsters, but they would have different lives, different names because they don't know. They're not copying each other. They're just the same thing.
Yeah. Well, they're in different spots too, right? Like they're in different
way far away.
Yeah.
Way far away. We will never get to see the other Chad, but we know he's there, and that's comforting in itself. It's cool. It's definitely cool. There. So it's impossible that it's not there. It's there over and over and over and over because it's already there again right here. And then you've got this, which makes it everywhere, millions of them. And then you get down here, and Chad's just not a big deal.
Yeah.
Chad happens. There's only so many ways to do this. Now that's because the reason why is because we can't take building blocks from down here and put them up here. So each hamster cage only has so many building blocks in it, and we have to build the whole Chad scenario in each cage. Mm-hmm. So there's so many cages that we can do it the same Chad over and over and over. But if you were to combine, if you were to break the glass out and connect all the cages, then it would be once again there would be too many Lego pieces. But since we have them in cages, the cages, we have too many cages and not enough blocks in each one. And that's a very easy for science to calculate. So Chad is out there again. Guaranteed he has a different name though. I mean, the more we think about it, we just solve that, we come up with, that's what is cool about this stuff. Like there's no reason why, like you don't have the same car, you have the same body, the same brain, the same biology. Mm-hmm. And then it'd be fun to see, but you probably have a life that looks pretty similar. Because if you have the same biology, so does everyone else, or else it's not the right world. It's 100% correct world, remember? So your mom is with your dad. They might have different names, but everybody... Now, the reason why your mom is with your dad is not because they have to be. It's because this world started with the same things intact as this world. So the same initial interactions happened with the same initial beings because it was all arranged the same to begin with. Like the egg was the same when it was hatched. And so this subject A walked past subject B in day one. And he said, whoa, look at you, because they were both the same person. And so they're like, I like that one. And the other one's like, I like that one. And then over here, the same too. I like that one. I like that one too. And they didn't know that they said it here. But in the beginning, it'd be hard for because you have to set up Earth on day one with the same puzzle pieces. And then when you hit play, it's going to be hard to deviate. It's gonna the same things are gonna happen because those are just natural reactions. So you're going to 9 times out of 10, you're going to end up with the same couples because in the beginning of time, the same interactions happened, and then it became a mass chain reaction of the same thing. Mm-hmm. But there might be some deviations here and there, maybe. I don't know. That'd be interesting to see. It'd be interesting as fuck to see. I'm going to say that your parents would be still your parents because you would still, in that world, you would still be an offspring of them. And that's how you became to be the same thing. I'm going to say that being the same Earth means being the same Earth. That everything has to probably fold out the same way. Anybody along the way can probably break the cycle, and then get that cage out of here. Mm-hmm. And so on the place where... So I'm thinking the proper hamster cage to have the other Chad in it has been an Earth sequel from day one till day Chad. It has not deviated from Earth in that whole time because these building blocks, so yeah, all 18 trillion of them are in the same place as today, as today on both places. But I'm saying they probably have been every day. Mm-hmm. As the Earth changes around its building blocks, so does Earth too, because but they don't have to exist at the same time. So you could be a baby here, or you could be a million years away here. It's just that you're going to happen here next. And that this is Earth. This has This could have dinosaurs on it now. But it's going to be you. And if the dinosaurs don't ever get wiped out, then get rid of that hamster cage. That's not Earth. The dinosaurs have to, everything has to follow. But there's plenty of cages. So just go to the next cage. Oh, here we go. Here's another Chad. Oh, here's another check. Eventually, you're going to find one that has the same landing. There's no way around it. We are not that uncommon because there's too much out there. The only thing I don't really know is what moved the first movement. Supernovas are what's moving everything from now. So what I'm doing is I'm showing you how this thing is growing and advancing, but I don't know how it started, and I know how it's continued to go. So I don't. But that seems kind of also logical. It's a lot easier to understand like how something grows up than it is how that egg makes it. So I don't know how this thing is birthed, but I know how it grows and I know how it dies. And so just if you close your eyes and you just imagine a time lapse and you imagine the everything moving, and it happens to be moving in a swirling pattern because the black hole won't let go of it all together. Oh, you know why they're spiraling outward from a black hole? Black hole, supermassive black hole, spiraling outward. Because everything that's not spiraling inward is going too fast to stay. So it's orbiting it, but it's going too fast, and so the black hole is losing it, or the other way around maybe. But I think So like this thing came in, but keep in mind it's not glowing like when it's coming in, and this is on an astronomical level because this is whole galaxies. But I just had an epiphany, but it needs more thought. But that all of the stuff that is going too slow is right here, and all of the stuff that is going too fast, single file somehow. So like the stuff would be coming in from everywhere, but it might come in single file and leave in mass fucking transit because they're coming from everywhere. So you don't see the disruption of it all coming in. But if it gets stuck in the middle, it just creates the orb. And if it's too much acceleration on the input, it spirals its way out. And there's just a train track on the way out, you know? And there's no wind, so the longer we live, the more it gets, the first pieces get farther away and the bigger it gets, and because more keeps coming in, and it just keeps sending out what's too fast. That's probably close, you know? Close. I need more thought on that, but that's close. And let's just call it there. Because from there, one of my ideologies, or my not ideologies, my philosophies is that when you plant a seed in someone's mind, it will grow. The longer they live, the more it will root and grow and evolve and advance. And so I will not stop something until I get that seed planted. And then once that seed's planted, I'm satisfied, even if there's more that I could teach you, because that seed will now grow over time. You have no choice. Even if you don't think about it again, or even if you don't like me or don't like what I said or don't believe it, you don't have a choice of whether or not that seed will grow. That's the beauty of it. I do. I made the seed, and so if it's a viable seed, it will grow because you're fertile soil and you don't have any control over. You would have had to leave and not let, but if you stayed and let me put the seed in there, then now you are out of control whether it will grow or not. And because tomorrow you might see something that, like, you might see a bubble form in water, and it might give you an epiphany, and you'll be like, holy shit, and a bunch of things will ding 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 Tetris together, and all of a sudden a chunk comes out of what I just taught you, and then next time I see you, you're excited to tell me, like, you won't believe what I saw about, and I might be like, it's not a big deal to me. I'll try to act excited because I'll be glad you at least are thinking about it. But to you, you believe me more now, and to me, I'm like, yeah, I know. Well, duh, that's why I said that. You know, that's what I was thinking. That's what I told you. And you're like, yeah, but I didn't know what you meant until I saw the bark fall off the tree. And then so then the longer you live, if it's a good seed, there's no stopping it. The longer you live, the more prolific of a plant it grows. And eventually, it's your whole. Eventually, you're a scholar, scientist, philosopher, just like a second generation element.
Mm-hmm.
Your tree is now. I don't listen to you, but you have your own students. Me and you are equal. Like we're teachers across the hall, but we both have a classroom now, and it's all because I planted a seed. And so at this point in time, I'm going to say, introduction to astronomical physics, seed planted. You have no choice but to learn more about what I just showed you the longer you live, because you will see things that remind you of things I said that will, and the thing is, every time you run into one of those things, it will fit the bill. The protocol that I laid out, don't use the numbers because those were hypothetical, but the theories will fit every physics interaction you ever encounter. Every if you imagine like the bubble and the black hole, or you imagine the hamster cage and the earth, everything will fit in. You know what I mean? Every small unit will be like subatomically correct to the larger unit, or scale size compatible, or like the little Chinese dolls where the one doll fits inside the next doll, inside the next doll, inside. Mm-hmm. If you run into a oblong shaped doll, then that would be bad theory. That seed wouldn't have grown. Because that's right there where the tree died. You found out that it didn't fit in the next piece, and so all the roots went black and the leaves fell off, and it wilted up and died. And you laugh about that one time Tabby tried to plant a seed in your brain. It died on a rock, like hers died tonight. Mm-hmm. And mine will grow a big old tree, and then you will eventually get your own. You will never need me again, because you will have your own grasp that is rooted, and it is. And what's beautiful is it's not mine, because humans do not. I did not brainwash you, and I'm not your dictator. And so I planted a seed, but you have to grow it, and what you see in life is what guides the growth of it. So when you get done, I'll be curious to see what grows, but I won't be able to draw it right now what it is. It will be, because you should never take someone's advice directly. You should always take it as an inspiration to directly create your own. Your tree that grows might be, it could be anything. It could set you off on a whole new journey where you're this new something that I don't even do, because it caused you to have an epiphany that I didn't have. But all I'm saying is that the longer you live, as long as you have eyes, as long as you don't go deaf or blind, then the tree will get bigger and bigger. And the more it gets bigger, the more it will be an unknown form to me. And the more you will have your own power on said topic. And then this tree, instantly, you have these seeds now that you can flick in anybody's garden that you want, that grow off of your tree. And those, I don't have any of those. I have the maple tree that I put here, but this is the maple hybrid Gen 2 that you fed. And I didn't feed this one. I don't know if you miracle growed it or not, or what you did. So all I could do is watch you plant one and see what grows. But then once you have plantable seeds from this tree, now you're a believer. Now you know what they are. Now you're a philosopher. Now you can think and create seeds, and then you can flick them wherever you want.
Sweet.